Look up at the night sky. For 4.5 billion years, our cosmic neighborhood has followed a strict, clockwork rhythm. 9 planets, then 8, revolving around a single, reassuring star. Until now. Drifting out from the black, abyssal cold of interstellar space, a cosmic titan has breached the inner solar system. It is a rogue behemoth, an object larger, heavier, and far more violent than Jupiter itself, and it has just locked into position directly outside Earth's orbit. It isn't a comet passing by. It isn't an asteroid we can nudge off course with a rocket. It is a planetary sovereign weighing more than 300 Earths combined, parked just millions of miles beyond our world. Its monstrous gravitational pull is already reaching out like invisible fingers, tugging on our oceans, destabilizing our atmosphere, and altering the very path Earth takes around the Sun. What happens when a world big enough to swallow 1,300 Earths invades the delicate gravitational ecosystem that keeps our planet alive? Can humanity survive when the delicate equilibrium of our orbit is ripped apart from the outside? Before we analyze the staggering physics of this cosmic invasion, make sure to hit that follow button right now. We break down the most extreme scientific realities and cosmic phenomena in the universe, and following this page ensures you never miss a deep dive into the mysteries of space. To comprehend the scale of this threat, we must first understand what kind of cosmic entity could possibly achieve this. In astronomy, Jupiter has long held the crown as the king of our solar system. It contains more than twice the mass of all other planets in our system combined. But in the deep galaxy, Jupiter is merely a lightweight. Astronomers classify objects larger than Jupiter into 2 primary categories: super-Jupiters and brown dwarfs. A super-Jupiter is a gas giant that grew to enormous proportions during its formation, possessing up to 13 times the mass of Jupiter. A brown dwarf, on the other hand, is something even stranger: a failed star. Brown dwarfs are bodies between 13 and 80 Jupiter masses. They are too massive to be considered ordinary planets, yet just shy of the mass required to ignite sustained nuclear fusion in their cores like our Sun. These objects are cosmic nomads. Born in distant stellar nurseries, they are often kicked out of their original star systems by gravitational chaotic interactions. For millions of years, they wander through the dark voids of space at tens of thousands of miles per hour, invisible, freezing, and silent, until their path crosses a solar system like ours. Positioned just outside Earth's orbit, roughly around 1.3 to 1.5 astronomical units from the Sun, this intruder has entered the sacred, habitable zone. It is now closer to us than Mars ever gets. And in celestial mechanics, distance is everything. Why is an object positioned outside Earth's orbit so catastrophically dangerous, even if it never directly collides with us? The answer lies in Isaac Newton's law of universal gravitation. Gravitational force scales directly with mass and decreases with the square of the distance. Earth relies on a nearly circular orbit around the Sun to maintain its mild, stable climate. But an object larger than Jupiter, positioned just beyond our path, acts like a secondary gravitational anchor. Every time Earth passes close to this giant during its annual journey, the Titan's massive gravity tugs on us. What happens when that tug-of-war begins? First, Earth's orbit stretches. Our circular path becomes highly elliptical. In orbital mechanics, this means Earth spends part of the year plunging much closer to the Sun and another part of the year swinging out toward the freezing shadow of the giant intruder. Have you ever wondered how sensitive Earth's climate truly is? A shift of just a few percentage points in our distance from the Sun would destroy the delicate thermal balance that keeps our oceans liquid. Under an elliptical orbit forced by this gas giant, Earth would experience wild, unlivable seasonal extremes, blistering, ocean-boiling summers, followed by global, apocalyptic winter freezes, where the atmosphere itself threatens to frost over. But the disruption of our orbit is only the beginning. The immediate, terrifying impact would be felt right beneath our feet through a process called tidal flexing. We are used to our moon creating ocean tides that rise and fall by a few feet twice a day. The moon is small, but it is close. Now, place a Leviathan, 1,300 times Earth's volume, just outside our orbital neighborhood. The gravitational gradient from an object that massive doesn't just pull on ocean water. It pulls on the solid rock of Earth's crust and the liquid iron core deep inside us. As Earth rotates, the Titan's gravitational pull constantly kneads the planet like dough. Tectonic plates that have been locked for centuries would snap in unison. Fault lines across the globe, from the San Andreas to the Cascadia subduction zone, would trigger mega-earthquakes exceeding magnitude 9.0 daily. Underneath the crust, the extreme friction generated by tidal flexing would superheat the mantle, forcing magma up through every dormant fissure on the planet. Supervolcanoes like Yellowstone and Lake Toba would be squeezed into explosive activity, dumping billions of tons of volcanic ash into the stratosphere and blocking out sunlight for decades. The sky would darken, the oceans would boil at the equator and freeze at the poles. If tidal quakes and orbital collapse weren't enough, the Titan acts as a cosmic bowling ball smashed into a rack of billiard balls. Just beyond Mars lies the main asteroid belt, a graveyard of hundreds of thousands of rocky remnants left over from the formation of the solar system. Normally, Jupiter keeps the asteroid belt relatively contained, but an object larger than Jupiter parked just outside Earth's orbit completely disrupts the gravitational balance of the inner solar system. It would pull millions of asteroids directly out of their stable paths, scattering them across the inner solar system. Earth would be placed in the middle of a continuous, multi-century meteor bombardment. And what about our moon? Our lunar companion, which has stabilized Earth's axial tilt for billions of years, would face its own existential crisis. Caught in a gravitational tug-of-war between Earth and the incoming intruder, the moon's orbit could become wildly unstable. It could be flung entirely out of Earth orbit into deep space, or worse, torn apart by tidal forces, forming a temporary, chaotic ring of debris around Earth that rains lethal debris onto the surface. How could any civilization survive a multi-layered cosmic assault of this magnitude? When face-to-face with an interstellar intruder of planetary scale, traditional planetary defense systems, like nuclear deflection rockets, are completely useless. You cannot push a world 300 times the mass of Earth. So what options would humanity have? Science offers only two hypothetical paths for long-term species survival. First, subterranean geothermal vaults. Surface survival would become impossible due to extreme temperature swings, volcanic ash, and meteor strikes. Humanity's best chance would be retreating miles underground, relying on Earth's internal geothermal energy to power self-sustaining biospheres, hydroponic farms, and artificial ecosystems shielded from the chaos above. And second, the Great Exodus. If the giant's arrival permanently ejects Earth from the solar system, flinging us into the freezing void of interstellar space as a dead rogue planet, our only long-term hope would be launching self-contained, nuclear or fusion-powered generation ships to flee the dying system entirely. An event like this reminds us of a humbling truth. Our peaceful existence on Earth is not guaranteed. We live in a dynamic, violent universe where worlds are born, torn apart, and reshaped by forces far beyond our control. If an object of this magnitude entered our solar neighborhood tomorrow, which path do you think humanity should take? Retrench deep underground, or reach for the stars in a last-ditch exodus? Let us know your thoughts in the comments below. If you love exploring the jaw-dropping realities of astrophysics and cosmic science, hit that follow button right now. By following this page, you join a community of curious minds diving deep into the awe-inspiring, mind-bending phenomena that govern our universe. Stay curious, keep looking at the stars, and we'll see you in the next video.